guys, good morning. I am Shashi. I am from GPT Master Tank. My father name is Reddy and my mother name is Madhavi. I am here today because of my mother. She is a teacher. She is an inspiration of me. So today let's discuss about the IC555. Seeing the IC555 pin diagram, there are 8 terminals in it. First terminal is connected to the ground. It is referred as a ground. The second terminal of IC555 is known as trigger. Here where we apply the trigger input to the IC555. Here the pin number 3, it is known as output, where we see the output of the IC555. And pin number 4 is the reset pin. And pin number 5 is the control unit, control pin. Pin number 6 is the threshold. Pin number 7 is the discharge point. And pin number 8 is the VCC. This is the pin diagram of IC555. Here first pin number 1, here we will connect the ground to the IC555. And in pin number 2 we will apply the trigger pulse if needed. And pin number 3 we see the output of the IC555. And pin number 4 we use it to reset pin. For the if you used a IC555 once, if you want to reuse the IC555, the previous data should be deleted. That should be done by the reset pin. Next, control. Here when we go to the insert diagram, circuit diagram, we will use the use of the control pin. Threshold. This is a predefined voltage. And discharge, where the discharge will be taken place. And VCC, it is used for operation working of low inside op amps. Okay, this is a pin diagram. And this is the internal circuit of the IC555, where the 3 resistors are connected in a order that where the voltage is divided or in a series order. Each resistor is 5 kilo ohms. There are 3 resistors, so we call this IC as a IC555. The names come from this due to this resistors only. Okay. Here pin number 1 is ground. Here it is a ground. Next pin number 2 is a trigger. Here for the application of external signal we use the trigger. So here the trigger is applied for the comparator 2. Next, the third one is the output, where we will see the output waveform of the IC555. Here is the output pin. And next, fourth one, reset pin, where we use it to reset the data present in the IC555. Here the reset pin is present. Next, the fifth one, control. Here fifth one is a control. For the operation of comparators, we will use to have to choose 2 signals, that is positive and negative. One, it is signal 6. What is it? It is a threshold. It is a predefined voltage, and another one is a control. For the comparator 2, one is the voltage coming from the VCC divided by the resistors, and another terminal is connected to the trigger for the external input of signal. Next we have discharge point. It is 7, pin number 7. Here the discharge. And last finally VCC, pin number 8 is present here. VCC applied to working of this IC555. It is about 5 volts or 5 volts to 15 volts. Okay, next, this is the internal circuit of an IC555. Let's see the components of IC555. Here 3 resistors are connected in a series such that the voltage division takes place, and 2 comparators are taken for the comparisons of the trigger and control and threshold signals. Here 2 comparators we call it is a op amp. It is actually a op amp, but we will call this as a comparator because there is no feedback present. So if an op amp has no feedback, we call it as a comparator. And these two comparators are connected to a flip flop. It is RS flip flop. The flip flop is if R is equal to 1 and S is equal to 0, then Q is equal to 0. That means Q bar is equal to 1. If R is equal to 0, S is equal to 1 in the RS flip flop, then Q is equal to 1, Q bar is equal to 0. And this is a NOT gate power amplifier. Here we use NOT gate because we are taking output of the it is output of the RS flip flop is bar. So we are taking NOT gate to give it as a Q bar, to convert Q bar to Q. But we are using NOT gate. Why don't we connect to the Q? Because we are using a power amplifier here. If we take an external power amplifier, the circuit will be larger or bulkier. So the NOT gate itself has a power amplifier. It is known as complementary symmetric power amplifier. So we are using NOT gate and taking output of the inverting terminal. Okay, next. Here the output of the RS flip flop is connected to the two transistors as a base, as a collector. Okay, here this is a PNP transistor, and here this is a NPN transistor. Here it is connected to the reset pin for the operation of deleting previous data in the IC555, and this is used for discharging and charging of the circuitry. Okay, this is the internal circuit of IC555. Let us discuss about the application. For using IC555, we can create a waveform of square waveform by using astable multivibrators or monostable. Okay, let us discuss about the astable multivibrator. What do you know about astable multivibrator? Anyone? Two quasi states. That means itself changes the state from one state to another state with a time period of t. So we have to create a circuit such that itself can change the positive, I mean that plus Vsat to minus Vsat or 1 to 0, high level to low level, without applying any external input. Okay, let's see the schematic diagram of astable multivibrator. Pin number 1 is the ground. We are connected to the ground. Pin number 2 is a trigger input. So we in astable multivibrator we don't need any trigger input. So we are joining the trigger input and the 6 terminal threshold. It is a predefined value and is an external value. They both are short circuited. Okay. Next, pin number 7. It is discharge circuit, where we will discharge or charge the capacitor present in the circuit. Next, 8th one and 4th one. 4th one is a reset pin. 8th one is already VCC. For reset, if we given 1, if the VCC is, let us think VCC is high. VCC is high. If we given transistor, if we give a transistor 1, then it will be half. So that it cannot be, that means it cannot become 0. The output never become 0, because when a reset is given to 1, it will be on and referred voltage will be appear here. Let's assume the referred voltage is 1. If the voltage is here is 1, then NOT gate will change this 1 to 0. So in the view of this circuit, only we will get the output as 0, not refer to the circuit. So we will further off of reset, we use the VCC here. So we are shorted 8th pin and 4th pin. Okay. Next, now here we have to connect the external circuit to work this IC555 as an astable multivibrator. So for this we are using 2 resistors and 1 capacitor. Here, from here a resistor is connected. Let us assume this is a RA, and one more resistor is connected. It is RB, and 1 capacitor. This capacitor is used for changing time period or creating time delay, and this is all connected to ground. Here Here these pins are connected like this. You have a doubt that why should we connect only like this? Why should not we should connect like this? ఇలానే ఎందుకు కనెక్ట్ చేయాలి, వేలా ఎందుకు కనెక్ట్ చేయొద్దు అని ఉంటే డౌట్స్ ఉంటాయి కదా. ఒకవేళ ఇఫ్ యూ కనెక్టెడ్ discharge over here, it will be discharges up to 0 because there is no resistor here. The discharge time will be very fast. That means if you want to generate a pulse or a square wave, we need to have a high level or low level for some time, minimum time. If you connected over here discharging point, it will be discharged faster than previous. I mean that if you connected here, it will take 1 second. If you connect here, it may take 0.2 seconds. So we may not get the square wave like this, we may get like this, very shorter distance or very shorter time period it will change the state. So it is difficult to us for creating high frequencies. So we are connecting circuit like this only. This is standard. Okay, next let's implement this diagram in the components diagram. Okay, next let us see. First RA is connected to VCC. Let's connect it to VCC. This is RA, it is connected to VCC. Next RB, RA is series with the RB. Next series with the capacitor. And here ground. Now here terminal 2 and 6 is short circuited and connected to the point. Let us assume this point as 1 is connected here. Now here terminal 2 and 6 is short circuited, so we have to short circuit here, right? Next pin number 7 is connected to the between RA and RB resistor. So here is a discharge pin. Here pin number 7. Next the control. Okay, here is a 5 pin. 5 is connected to capacitor. Okay, here capacitor is connected to maintain the constant voltage across the 5th terminal. 5th terminal is a control. Control will decide the output of the upper comparator. So here the voltage is 2/3 VCC. We will get this 2/3 VCC by voltage division rule, and at here it will be 1/3 VCC. Here there is a terminal. There are 2 cases we can do with pin number 5. If we are grounded, this 2/3 VCC can be directly grounded, so the voltage across control is 0. So the comparator output is always 1. So it is not profitable or it is not useful for us. So if you connected capacitor, the voltage across 2/3 VCC will be charged here until we discharge. So the voltage will be here constant. So the voltage across inverting terminal will be constant, so that we can change the output as per our requirements. Okay, next this is a circuitry, and I said that for the off reset pin we should connect VCC. So this is the astable multivibrator circuit diagram with resistor RA, RB and capacitor C. Here it is a ground. Here we can connect these 3 terminals at a place, or we can separately give a ground. Here at output we will take the output of this astable multivibrator. Okay, let us see operation, how it works and how it generates the waveforms. First let us assume the output may be 1. Okay, I said that these 2 are the voltage across the terminals. So let us assume this is the 2/3 VCC and this is the 1/3 VCC and this is VCC. Okay, Okay, let's assume that the output of the Astable multivibrator 1. ఒకవేళ అవుట్పుట్ 1 అయి ఉంటే లోపల ఆపరేషన్ ఏం జరుగుతుందో తెలుసుకొని దాని తర్వాత ఆ 1 ఎలా వచ్చిందో తెలుసుకుందాం. 1 అనేది ఓకే. నెక్స్ట్ 1 మీన్స్ VCC. ఓకే, VCC. దిస్ ఈజ్ ద 2/3 VCC. Okay, if the output is 1, then the output of flip flop will be 0. If output 0, when we will get Q bar is 0, when S is equal to 1, that means that here it is on. Okay, here it is on. We will let us see why this is on. Okay, okay, when we apply the VCC to the RA and RB, here first let us assume that we assume that this is a 1, that means before the NOT gate it will be 0, so that the NPN transistor will be off. Here it is connected to the here and discharge. For the capacitor will do charging and discharging. Here for charging of capacitor, the voltage should come from the VCC. The path is this, and for discharging of this capacitor, the path is here, like this. The path is so. For charging it can be directly connected to the VCC, but for discharging here middle there is a Q2. When Q2 is on, only it will start discharging, but here the Q2 is off, so that this path is closed. So here the availability of capacitor is only charging. In the middle of charging there is only resistors, so that the capacitor start charging from the VCC to C. Here it is charging from 0. Initially the voltage across the capacitor is 0 because we never connected the voltage to the C, capacitor. So here the capacitor voltage starting 0 and getting 2/3 VCC. Here when the capacitor voltage is 2/3 VCC, it is connected to the terminal 2 and terminal 6, right? Here the comparator will do what will do if the voltage across 6, if the voltage across 6 is greater than V5, then its output is 1. Here the voltage across the capacitor is 2/3 VCC, that means the voltage across 6 also 2/3 VCC. When the voltage across capacitor అంటే 2/3 VCC కంటే ఎక్కువైందో అంటే ఇక్కడ దీనికంటే ఇది ఎక్కువ అవుతుంది అంటే అవుట్పుట్ అనేది 1 అవుతుంది. సో ఎప్పుడైతే దీనికన్నా ఎక్కువ అవుతుందో ఇక్కడ 1, the output is 1. Next compared to here, it is the capacitor is connected to trigger also. Here the voltage is 1/3 VCC. Here also same. If the voltage is less than 1/3 VCC, the output will be 0. So that here it will be 0. So here R is 1, S is 0. So output is 1. So here it is 1. So output will be 0. Okay. What will happen when the capacitor charges up to 2/3 VCC? The comparator 1 output will become 1 and the comparator 2 output will become 0. So the output of the flip flop will become 1. So that the output of the NOT gate will be 0. So the output will be from VCC to 0. Next the 1, here output is 1. This is connected to transistor Q2. When input is 1 for the Q2, it will become on. So on means the discharge point will be activated. So the capacitor is charged up to 2.3 volts, 2.3 VCC volts. So now it start discharging. The path of this discharge is like this. and it will become started decreasing to 1 by 3 VCC. Let us assume it is start decreasing, that means it is discharging, right? Here for the charging, the voltage should be cross RA and RB. So there are two resistors present between the charging points, so the time period taken will be more. But for discharging, it is directly connected here, only it will cross the RB resistor, so the time period taken will be less. Here the discharging started from minus 2 by 3 VCC to 1 by 3 VCC. When the discharging point, when here it is 1 by 3 VCC, the voltage across 1 by 3 VCC, it is connected here, that means here present is 1 by 3 VCC volts. At this point I state that if the voltage across two terminal is less than 1 by 3 VCC, the output will become 0. So output will become 1. Okay, is 1 by 3 VCC. Here the capacitor is started decreasing, so that let us assume this here voltage is 0.5 by 3 VCC. Here the positive terminal, that non-inverting terminal voltage is greater than inverting terminal, so output will become 1. VCC is greater than V21, output will be 1. Here the output will become 1. Next, here the voltage is 1 by 3 VCC. I said that if the voltage across positive terminal, that means non-inverting terminal, is greater than inverting terminal, output will become 1. But here the voltage across non-inverting terminal is less than the inverting terminal, so it will become 0. So what is the output if the set is 1? Set is 1, the Q bar is 0. So here output is 0. Here output is 0, so that here it will become off. That means when the capacitor reaches 1 by 3 volts, it stop discharging, and the output become 0 here, and the output become 1. So in the waveform, capacitor started discharging from 2 by 3 VCC to 1 by 3 VCC, so that the output will become 0 to 1. It is 0, at the point of time it will become 1, right? Next, same operation. After that sometime, that means this path is closed. That means the VCC, the capacitor started charging from the VCC, so that it will started charging from the 1 by 3 VCC to up to maybe VCC. Okay, let us after that started charging and reached 2 by 3 VCC. If capacitor reaches 2 by 3 VCC, here the output will become 1, because as per the comparator operation, if the voltage across in non-inverting terminal is greater than inverting terminal, the output become 1. After when output become 1, our Q bar is equal to 1, so that here it is started on, so that it started discharging. Here charging and discharging creates the changes in the outputs of the comparators, and due to change of output of comparators, the flip flop also changes the output of the output, so that here the output will be changes from 1 to 0 or 0 to 1. Okay, here same case, when the voltage across capacitor is 1 by VCC, the transistor Q2 will be off, so that it started charging up to 2 by 3 VCC. After reaching the 2 by 3 VCC, the Q2 will be on, so that it started discharging. It is a capacitor. Compared to the outputs, when the capacitor voltage is 2 by 3 VCC, the output become 0, so that previously it is 1, now it will become 0. And when charging, capacitor voltage is 1 by 3 VCC, so that output will become 1, 0, 1. Here it will be charging, this charging, here it is discharging, charging, discharging. Throughout the, when we on the switch, it started from 0 to 2/3 VCC and continued with 1/3 VCC. ఇట్లనే మొత్తం వేవ్ ఫామ్ త్రూ అవుట్ ఆన్ చేసి ఆఫ్ చేసే వరకు ఇదే వేవ్ ఫామ్ ఛార్జింగ్ డిశ్చార్జింగ్తోనే వేవ్ ఫామ్ క్రియేట్ అవుతూనే ఉంటుంది. ఇక్కడ హై, ఇక్కడ 1 ఉంటుంది, ఇక్కడ 0 1 0 1 0. మన అస్టేబుల్ అంటే ఏంది, జస్ట్ స్క్వేర్ వేవ్ జనరేట్ చేయడం. ఇక్కడ మనకి అవుట్పుట్ ఏమొచ్చింది, స్క్వేర్ వేవ్ జనరేట్ అయింది బికాస్ ఆఫ్ ఓన్లీ వీసీసీ, సారీ ఓన్లీ కెపాసిటర్. అంటే కెపాసిటర్ అనేది డిపెండ్ ఉంది. ఇక్కడ నువ్వు కెపాసిటర్ తీసుకోలేదనుకో డైరెక్ట్ గ్రౌండ్ అయిపోతుంది. సో నీకు అంటే ఈ ఛార్జింగ్ డిశ్చార్జింగ్ ఉండదు. దానివల్ల ఈ అంటే ఈ స్పైక్స్ వేవ్స్ రావు. ఈ స్పైక్స్ వేవ్స్ రాకపోతే ఈ అవుట్పుట్స్ అనేది చేంజ్ కావు. సో త్రూ ద సర్క్యూట్ ద major role will be the capacitor. If the capacitor is perfect, so the output we will get the perfect waveform. If the capacitor is faulty, we may not get the output, or we may not get a perfect output. Okay, let us see the applications of Astable Multivibrator. It is used for power pulse modulation, pulse position modulation. To generate a pulse position modulation signals, we will use Astable Multivibrator. For square wave generator or square wave oscillator, we use Astable Multivibrator. For FSK signals, we use the Astable Multivibrators. And for square wave generators or square wave oscillators, we use the Astable Multivibrator. Here in this we no need to apply any trigger external input, or we should not externally off or on any switch. Automatically it will change from the higher state to lower state with the creating one time period. We only can create a time period by using these resistors. The total time period across this Astable Multivibrator, that means one high level అనేది ఎంతసేపు ఉండాలి, లో లెవెల్ ఎంతసేపు ఉండాలి అనేది డిసైడ్ చేసేది రెసిస్టర్స్ RA and RB. నెక్స్ట్ ఈ పాయింట్ అంటే వేవ్ ఫామ్ ఎంత హైట్ ఉండాలి, ఎంత తక్కువ ఉండాలి అనేది డిసైడ్ చేసేది కెపాసిటర్. అంటే మొత్తం ఈ సర్క్యూట్లో ఈ 3A డిపెండ్ అవుతుంది కాబట్టి దీన్ని మనం ఎక్స్టర్నల్ నుంచి తీసుకుంటున్నాం. ఈ సర్క్యూట్ ఇలా కాకుండా వేరేలా కనెక్ట్ చేస్తే అవుట్పుట్ అట్లా రాదు, వేరేలాగా వస్తుంది, డిఫరెంట్ ఫ్రమ్ దట్. దిస్ ఎక్స్టర్నల్ సర్క్యూట్ యూజ్డ్ ఫర్ Astable Multivibrator. This is the common, this IC 555. If you connect this circuit IC 555, then it will work as a Astable Multivibrator. That's it. Any doubts?